Hello students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So today in this session, we will discuss the permanent hardness problems in the terms of calcium carbonate equivalence using EDTA method. So what is EDTA method? We will be using a ligand, that is EDTA, ethylene diamine tetraacetic acid in sodium salt form. So here before we use it for our titration, we have to standardize the EDTA solution. So for that we take the water and then titrate against EDTA. So the burette will contain, if this is the burette, this will contain EDTA, and we take the hard water in a conical flask. This is hard water. So we will be titrating with this EDTA, and there is a color change for this water sample. So with this color change, we indicate the end point, that is from the wine red to blue color. This is because of EBT indicator we add, that is iriochrome black tea or solochrome black tea indicator we are using. So whenever we add this indicator to the water sample, it turns to pink or wine red color because of formation of complex like calcium EBT or magnesium EBT complex. When it is complex, no place to. So magnesium EBT or calcium EBT is wine red in color. That is why it is wine red in color. And after titration, it forms calcium EDTA and magnesium EDTA. So this is actually colorless. So what is the blue color that is appearing? It is just the free indicator that is present in the solution. So it means that all the ions are complexed with EDTA and the indicator is free now. That is why it is giving this blue color. So this is the titration method we will be using to determine the hardness of that particular water sample. So here total hardness. So that is giving the total hardness in 1000 ml to report in mg per liter. When it is multiplied mg per liter or ppm. Whenever we are reporting in mg per liter or ppm, we have to multiply the value with 1000. So it is like giving the overall total hardness. So if we want to do the temporary hardness or the permanent hardness, then we will be titrating the solution again. So the first titration will give total hardness. Whatever is this present in that water sample. So after boiling, what happens? After boiling, temporary hardness is removed. That is, temporary hardness is removed. Assuming that carbonates and bicarbonates removed as carbon dioxide when it is boiled. So whenever we are using this hot water for the titration, it means only permanent hardness is present. Only permanent hardness is present whenever we are titrating the hot water or hot solution. So that is giving the permanent hardness. So from the total hardness and permanent hardness, we can determine the temporary hardness. So total hardness is combination of both temporary and permanent. After boiling, when we titrate, it will give only permanent hardness. So temporary hardness is equal to total hardness minus permanent hardness. This is how we will be calculating the temporary hardness, total hardness and permanent hardness using EDTA titration method. This is also called complexometric method, wherein the metal ions are forming complex with the EDTA. So let us go into the problems and understand how do we calculate theoretically. So a water sample of 100 ml required 8.4 ml of 0.02 molar EDTA. It means what are we doing here? EDTA is taken in the burette and the titer value is 8.4 ml. So 8.4 ml of 0.02 molar EDTA with EBT as indicated, iriochrome black tea or solochrome black tea. So after removing the carbonate hardness, what is this carbonate hardness? Carbonate hardness is the temporary hardness. Carbonate hardness is nothing but the temporary hardness. So we are removing this carbonate hardness. What does that mean? It is like we are titrating with the boiled water. So now calculate the permanent hardness in terms of calcium carbonate equivalence. So we what is that given here? Like 8.4 ml of 0.02 molar EDTA. If you see that the concentration is fixed for EDTA, at least one of the concentration should be known, that is nothing but the EDTA that we are titrating with. So for 100 ml of water, after removal of temporary hardness, that is nothing but carbonate and bicarbonates are removed by boiling the water. So now we will be using this formula. M1V1 is equal to M2V2. M1M is the molarity or the concentration. V is equal to volume. So what is the volume of EDTA and volume of water? We know the volumes of EDTA and water. So what is that? We want to know the concentration of water. It means nothing concentration of hardness causing salts present in that particular water sample. So M2 is equal to M1V1 by V2. So here what is it? This is the molarity of EDTA, that is already given in the question. 0.02 into 8.4 is the titer value, that is the EDTA volume, by 100. 100 is the volume of water that is taken. So what did we get? 0.00168 molar. So this is the concentration of hardness causing salts that is present in that particular water sample. So now we will calculate the permanent hardness. It is nothing but the molarity into 100 into 1000, that is giving rise to 168 ppm or mg per liter. We can either write it in the form of mg per liter or ppm, parts per million. So this is how we will be calculating the permanent hardness in terms of calcium carbonate equivalence. Next is like 50 ml of water consumed 15 ml of 0.01 normal EDTA. So what is the titer value here? Titer value is 15 ml and the concentration of EDTA is 0.01 normal EDTA. And what is the volume of water that is taken? 50 ml of water is taken. Hard water is taken. So before boiling, it means it contains both temporary and permanent, and 5 ml of same EDTA after boiling. So after boiling, it contains only permanent hardness. So what is that? 5 ml after boiling. So 50 ml of water is sample is equal to 15 ml of 0.01 normal EDTA, that is nothing but 15 into 100 by 50. So that is giving rise to 300 ml of, that will give rise to 300 ml of 0.01 normal EDTA. It is like volume of EDTA V1 and 15 ml is a V1, and then 100 ml is like we are calculating, converting into liters, so that is giving rise to 300 ml of 0.01 normal EDTA. So 2 into, what is that again? 2 into 300, like 2 times, like 2 both the permanent and temporary are present. So 2 is a normality, we are converting into molarity. So for converting into molarity, we are multiplying with 2. So 2 into 300 is equal to 0.01 normal EDTA. So that is giving rise to 600 ml or 0.6 liters of 0.01 equivalence of calcium carbonate that is present in the present water sample. Okay, so then converting into grams, 0.6 into 0.01 into 50 grams of calcium carbonate. Why? Because it is in the normality, so that is why we are taking 50 grams. So 0.6 into 0.01 into 50 grams, that is giving rise to about 0.3. Nothing but 0.3 grams or 300 milligrams of calcium carbonate equivalent. So this is the total hardness that is present. Why we are taking total hardness? Because it is before boiling, it contains both temporary and permanent hardness. So total hardness that is present in the water, 300 milligram per liter or 300 ppm. Next is 0.5 grams of calcium carbonate was dissolved in HCl, and the solution made up to 500 ml with distilled water, and then 50 ml of the water required, the solution required 48 ml of 50 ml of solution required 48 ml of EDTA for titration. Then 50 ml of hard water sample required 15 ml of EDTA after boiling. So after boiling, 50 ml of hard water required 15 ml only. If you see the values also, it contains only permanent, that's why it required only less volume of EDTA, and filtering required 10 ml of EDTA solution. 50 ml of hard water sample required 15 ml of EDTA, and after boiling and filtering 10 ml of EDTA. 15 and 10 ml of EDTA, that is for the permanent hardness. Now calculate the temporary hardness if the total hardness. So they have already given the total hardness, that is 312.5 ppm. So if you see whatever they have given, like we will understand in the form of calcium carbonate equivalence. So 500 ml of standard hard water, that is prepared in the distilled water. Standard hard water, we are intentionally preparing the hard water, so that is the standard hard water is equal to 50 grams or 500 milligrams. 500 0.5 grams is also written as 500 milligrams of calcium carbonate equivalent. So now we got it in the calcium carbonate equivalence. So 1 ml of, then how much will it contain in 1 ml of standard hard water? It is 1 mg calcium carbonate. If it is 500 ml of standard hard water containing 500 mg, then 1 ml contains 1 mg of calcium carbonate. So 48 ml of EDTA is equal to 50 ml of, so the titer value EDTA that is consumed is 48 ml. 48 ml consumed for 50 ml of standard hard water, that is equal to 50 mg of calcium carbonate. How did we get this? Because like 1 ml is equal to 1 mg, so 50 ml is equal to 50 mg calcium carbonate equivalence. So 1 ml of EDTA will be 50 by 48 milligrams of calcium carbonate equivalent. So this is like we have to remember this for 1 ml of EDTA. We will be using in further calculations for the permanent hardness. 1 ml of EDTA is equal to 50 by 48 mg of calcium carbonate equivalent. So total hardness is already given, that is 312.5 ppm. So now the permanent hardness, what is the permanent hardness? 50 ml is boiled, 50 ml of water is boiled, 50 ml of water is boiled, that is consuming 10 ml of EDTA. If you see here from the question, we have written down like 10 ml of EDTA is consumed for 50 ml of boiled hard water, that is for the permanent hardness causing salts. After boiling, it will contain only permanent hardness. So the boiled water is consuming 10 ml of EDTA. So 10 into 50 by 48. Why is it? Because for 1 ml, for 10 ml, for 1 ml, it is 50 by 48 mg of calcium carbonate. So for 10 ml, how much? So for that, we are multiplying with 10 into 50 by 48 mg of calcium carbonate. This is just to convert into calcium carbonate equivalent. So that is coming around 10.417 milligrams of calcium carbonate equivalent. So for whenever we are reporting in ppm or milligram per liter, we have to again multiply with 1000 ml. So 1000 ml of boiled hard water is equal to 10.417 into 1000 by 50. So that is giving rise to 208.3 mg of calcium carbonate equivalent. So that is also reported in the form of ppm or mg per liter, that is 208.3 milligram per liter or ppm. So whenever there is this is a question like standard hard water is prepared, the hard water has to be converted into calcium carbonate equivalent. So once we convert into calcium carbonate equivalents, that has to be multiplied with the present volume that is consumed for the permanent hardness calculation, that is the EDTA volume that is consumed for the permanent hardness. So ultimately we get only the permanent hardness. So as the question has already given the total hardness, it is like we are considering the total hardness and going further for the permanent hardness calculations. Next is a 50 ml of water sample during each time of titration against soap solution. So now we are taking soap solution in the conical flask. So we have a burette containing EDTA and the conical flask contain soap solution. Why are we doing? Because to understand the lather formation. So that gave the results. Permanent hardness is 12.5 ml, that is the titer value, that is the volume of EDTA. Then lather factor is equal to 0.5 ml. So what is this lather factor? Lather factor is nothing but the volume consumed for producing lather for the distilled water. Okay, so now the standard hard water is equal to, for whenever we are titrating the standard hard water, it got a value of 40.5 ml. It is like we have prepared intentionally the hard water using distilled water. So now calculate the permanent hardness in terms of mg per liter or ppm. ppm is parts per million. Okay, so lather factor, like I have told you, that 50 ml of distilled water titrated by soap solution is giving rise to some lather, that is nothing but lather factor. Okay, so 50 ml of boiled water. If you see the question, 50 ml is taken. Boiled water. This indicates boiled water is consuming how much? 12.5 ml of permanent hardness minus we have to subtract this lather factor. Why? Because we are taking the soap solution in consideration, so we have to subtract the lather factor. So what we get now? 12 ml of soap solution, that is causing the permanent hardness. Okay, so 12 into 0.5 or it give rise to 6 mg per 6 mg calcium carbonate equivalents. So this is nothing but in the terms of calcium carbonate equivalents. So 1 liter of boiled hard water, BHW is boiled hard water. Boiled hard water, that is nothing but 6 mg into 1000. Whenever we are giving 1 liter is equal to 1000 ml, so we multiply with 1000 divided by 50, that is the equivalent weight of calcium carbonate. So is equal to 120 mg of calcium carbonate equivalent. So now we have successfully converted into calcium carbonate equivalents, and that is again equal to permanent hardness. It is like 120 mg per liter or ppm, parts per million. So we can either when the question contains mg per liter or ppm, it indicates the same, but the reporting has to be done after multiplication with 1000 ml because it is reporting in the form of 1 liter. So ppm also requires 1 liter conversion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.